All right.
Joking on comet dust.
I'm sorry. Okay, so we've been talking a lot about this asteroid belt. And the reason we're doing it, thank you very much, is because this asteroid belt is extremely important to the production of a lot of the meteors that we see. But what I'm going to talk about a little bit is where it comes from. Because it's an important thing in science to always question things, everything. So you hear us talking about asteroid belts and comets and stuff like that. The first question should be, where did they come from? Well, like we were saying, the asteroid belt is between Mars and Jupiter. And what happened is, early on in our solar system's life, after all the planets had been formed, there was all this debris, a whole bunch of rocky dust left over. And over a period of millions and millions of years, these rocky debris is grouped together. And some of them grouped together in the asteroid belt, some of them grouped together beyond Neptune in a place that we call the Kuiper belt, and some others grouped together in what's called the Oort cloud. And those are what I'll be talking to you about. The asteroid belt is that if you calculate the total mass of the asteroid belt, you add up the weight of all the little particles of grain and sand that's in there, it only weighs about 4% of our moon. So it takes up a whole lot of space, but it doesn't weigh that much. And the reason is because in the early solar system, Jupiter had so much gravitational dominance that instead of all of the rocks slowly combining together to form planets, they smashed really violently. And that violent collision caused them to break up and turn into the tiny dust particles that we see. And you can think about it and realize that whenever you have something that gets collided, it's going to send fragments everywhere. Like if you drop a glass cup. Anybody broken anything made out of glass before? You notice how you drop it and it just shatters and goes everywhere? It's exactly what happens in those collisions. So when that happens nowadays, that's where we get those sporadic meteors from. But what about comets? Anyone have any ideas where comets may come from? Okay. Anyone else? Don't be shy. Throw out ideas.
You guys don't have to raise your hand.
Yeah, you can just shout it out.
You know the layout of our solar system, where all the planets are? The very last planet when I was a kid was called Pluto, as we mentioned before. They changed that recently. So now that our last planet is actually, this is the wrong model.
It's not wrong.
Well, yeah. It'll be right here. So go ahead.
So, as you saw earlier when I had to put these gloves on, and I still do because this is very, very cool stuff.
And it's so cold it'll burn your hand.
Yeah. This right here has what we call dry ice in it. And dry ice is, like I said, is negative 110 degrees below zero.
So a lot colder than any snow day.
So if you touch this with your bare skin, it can do damage. Well, the reason that comets are so cold is because, like I said earlier, they originate past Neptune. They're really far away from the sun. So as a result, it's really, really cold in this region. But Neptune is a rather large planet. Don't be fooled by this model because the scale here is not right. So they're actually a lot bigger. And Neptune's gravity will slingshot these comets out of their orbit here and send them into our solar system where we reside and where the sun is. And then you get the process that she talked about where the sun's rays will begin to melt and vaporize it, and it will begin to glow, and that's what we know as a comet. But the Kuiper belt produces short period comets, which means that as they're revolving around the sun, like the most famous short period comet is Halley's Comet. Anyone ever heard of that? Anyone ever heard of Halley? Who actually got to see Halley's Comet? The adults. Halley's Comet only passes around once every 76 years. And anything that has a time of less than 200 years is what we call short period. Long period comets come from way, way, way out, way far out at the edge of the solar system in a place called the Oort cloud. And what happens in the Oort cloud is they get shot down towards our solar system, but they're so far away that that orbit, one rotation, can take thousands and thousands and thousands of years. And that's why we call them long period comets. Now, I noticed a lot of you had a lot of questions, and I imagine that some of you have questions because this is a very complicated subject. So if anybody wants to ask any questions right now, feel free. Okay, what's up? Actually, well, what do you think? What do you think about aliens? I want to see if you can... Do you think they exist? You do? What about you? Yeah, I've seen that too. Now the thing, yeah, have you seen that?
No, but I was watching way out of the solar system, there's an unusual planet.
Planet X. I think that's what they're calling it.
Yeah, and then they sent this rover up there shining light on it.
Well, if we're going to talk about aliens for a little bit, we're going to mention some of the things. Life requires some basic things. One of them is water. So when we look for life on other planets, we have to look for planets which contain water. And in fact, the most viable source for life in our solar system is not on a planet. It is on a moon that orbits around Jupiter, and it's called Europa. And Europa has a lot of liquid on it. So, given the vastness of space, because it is a huge, huge place. To give you some perspective on the vastness of space, the distance between the Earth and the Sun, we call an astronomical unit, that distance is over 1 billion football fields laid end to end. It is a total distance of 92 million miles, and that's just from the Earth to the Sun. So we have galaxies, and we have the universe as a whole, so the odds are that there may be some form of life out there.
And if you ever wanted to study that in college, it's called astrobiology, where they study organisms that are not just like people, but like bacteria or smaller animals.
I have this enormous telescope with a whole lot of things.
Mm-hmm.
And I see shooting stars.
Yeah, and most of the shooting stars that we see that are not part of planned meteor showers, like we've been saying, come from that thing called the asteroid belt. So what you probably saw was a rock that got knocked out of its original location and shot into our atmosphere.
I love his ginormous, too. That's
Yeah.
great. Ginormous. Yeah,
You what's up?
So Rovers is discovered life on planet X?
No, there's no, as of right now, there's been no discoveries of life on another planet. But we are investigating, because that would be really cool to see.
And we have found bacteria on, when we've landed satellites and rovers on asteroids and meteors, and they have recovered some bacteria. And when you find meteorites as well, that's one of the other things that they look at, is the different types of bacteria that they'll find on them.
Have you found like any kind of planet with no gravity? With gravity?
All planets, or anything with mass, you have mass, like you weigh something, so you have gravity. Anything that weighs something has gravity.
The same gravity as this planet. Have you found anything?
Okay. There, like he mentioned them, I believe. There are planets that live that are outside of our solar system, and they're called exoplanets. And these exoplanets, we have found some of them that have the same size as Earth. So to answer your question, yes, we have found planets that orbit around a star and have their own gravitational field similar to ours. What's up?
Okay. Finding these rocks with bacteria. What if we don't have immune systems for that particular bacteria?
That's something that astrobiologists are worried about, because you introduce new types,
we went to see the Indians and they got smallpox from us.
Right.
And this is on Earth. So if we're bringing bacteria that we don't know about.
There's actually a really interesting novel called Tyrannosaur Canyon that introduces the idea that the asteroid that wiped out the dinosaurs, there's actually a bacteria that was present on that asteroid. And a lot of astrobiologists are concerned about that, because we have various different types of vectors, which are the ways that bacteria gets into
Okay, but I don't believe that, the dinosaurs. That would take too long, wouldn't it? I mean, I think more like the dumps than they kill the plant.
Oh no, it was a fictional piece.
Good.
This young man has a question.
Is there an asteroid field?
Yes, that's what that asteroid belt, the reason we call it a belt is because it loops around our solar system the same way that my belt wraps around my waist. And it's contained a whole bunch of big rocks, and that are exactly what you're talking about, asteroid fields. You've probably seen in space movies where spaceships are flying through all these asteroids and they're colliding together, right? That's exactly what's going on. Yes, ma'am.
And also over in our exhibit, Space in the Yard, if you've seen the full scale model of the first spacecraft that's powered by solar, that landed on an asteroid.
Good.
Yeah, that's
1996, and it's still functioning and sending information.
So it's still sitting on the asteroid.
Yep.
Yeah, that's the, it's called the Near Shoemaker satellite.
Okay.
And it, like she said, it landed way back when, but we launched it a few years prior to it actually landing.
So are we sending germs?
Well, yeah,
Our germs?
technically, because you can't really eliminate any type of
Okay.
bacteria. We're also trying to find renewable energy sources, not necessarily renewable, but different types that we could harvest for Earth, because we're running through our own resources.
Well, she mentioned diamonds, and this is the diamond part. It may be a little off topic of meteors, but this is really cool. And I think you guys have all seen a diamond, right? They're really pretty.
No.
You don't
You
need
don't like
diamonds?
diamonds?
No, I never seen that.
Never seen a diamond? Okay.
How about in your mother's friend? My mom has a diamond. In my mother's friend.
Yeah, a lot of women do.
Well,
Yeah,
yeah, inside of a star, like our sun is what's called a main sequence star. So it's a fancy name, and that means that sun will produce the element carbon. It produces hydrogen, it produces helium, lithium, beryllium, and carbon, the first 5 elements on the periodic table. Anyone know about diamonds? What do you have to get? You have to you need pressure. What else do you need?
Carbon.
You need carbon, that's right. And
Superman did it in a movie.
And the very last thing you need is heat. So the heat of a star towards the end of its life, mixed with the pressure of all the gas within it, will cause a diamond to form. And the theory is that inside of what are called white dwarfs, there resides a core of a diamond. Not the pretty diamond you're all familiar with, because it hasn't been cut and designed, but it is the same physical characteristics as a diamond. But to go back to the topic of today, since we're closing out, the asteroids that you see and that come in, we call those
Sporadic meteor showers.
yeah.
They
Sporadic
collide.
means once in a while.
Yeah, and like I said, we normally don't know when they're actually going to occur. NASA only finds out, if they find out, about 3 days prior, because they're so random. Now, and the other ones that we're talking about were called annual meteor showers. They result from comets. So we know because we trace the path of the comet every year. So what do you think we need to be able to see meteor showers, guys? Telescope. What else?
Darken my eyes.
It needs to be dark out, so if you live near a city, you have to go a little bit outside the city just so the lights in the city won't interfere with the meteor shower. You actually don't need a telescope. It's better to view it just with your naked eye, because a telescope limits the field that you're going to be seeing it in. So you can use this. People often use binoculars as well. This is a space binocular, so it's kind of like a miniature telescope. You also can use star charts. This basically has all the constellations in our night sky in our hemisphere, because comets and meteor showers are named after the comet and the constellation that they originate from. So if you're in December, if you're looking, you can use this to find the constellations for the Draconid.
Do I have the paper?
Yeah, we actually have a list of different upcoming meteor showers that you guys can watch. They also tell you that the times that you should go out and how many are going to occur in the night sky per hour.
Like, if you live in, like in a apartment and you have houses connected, would you be able to see them?
Is there a lot of light? Yeah.
They just have like the town lights. Sometimes you'll just see a small bit of light from the house. And then you should go pretty far.
Well,
But we have, but it's like a big
yeah. Well, you can go out into the country. Now, we talked about a lot of stuff. It's science. Science gets very complicated. So now, instead of talking about a whole bunch of really complicated things, if any of you want, I can take you upstairs for about 5 or 10 minutes and show you a really, really cool chemical reaction that takes place to form comets. And it'll produce a whole lot of moisture, a whole lot of fog. It'll make some scary noises, but if you are interested at all, come on up and see me, and I'll be playing with some chemicals.